Hello and welcome to this new video. Today we're going to thoroughly explore how to effectively set up a virtual private network or VPN utilizing Border Gateway Protocol, BGP, to seamlessly share internal network resources with a remote site. Now, I'll try to explain it to you in the simplest way possible, and I'll also try to give you as many examples as I can, explaining what I actually did in the configuration that is already working. So I'm not starting from scratch, but I'll show you all the necessary steps to achieve the result and point out some differences. So let's start right away by looking at the firewalls. This is the one on the left, as it says here, left, and then we have the one on the right. Just a moment while I grab the highlighter. This is the one on the left, and this is the one on the right, as you can read here. This is the lab. So, first of all, there are two things. I'll come back to this point later, but I'll tell you right away. Here we have our left firewall, which is this one, and it receives the BGP routes directly. That is, BGP is configured directly on the firewall here, while on the right side, BGP is configured directly on the router. In this case, well, on the routers. Why am I telling you this? Because you'll see it later on in our discussion, and I will definitely come back to this particular point anyway, since right here in this specific configuration, you will observe some BGP routes, which are Border Gateway Protocol routes, that you absolutely will not see displayed on the right-hand side firewall. So at first glance, when you initially look at it, you might be a little bit puzzled, perhaps even get a little bit confused or disoriented, let's just say. But let's proceed now and see if I can thoroughly explain to you precisely what I have accomplished and implemented here. Anyway, this is the goal. Here, I currently have two distinct networks, specifically Network 1 and Network 2, both configured on the left firewall. Conversely, in this particular case, I possess one primary network situated on the right firewall, which is precisely this network located here, identified as 192.168.80. This specific network is the one I intend to share with the left firewall, and consequently the right firewall will receive the routes actively sent by the left firewall. Now, having said that, let's take a moment to see how everything is configured. As I already mentioned, it's already set up and working, but I'll show you all the steps. So, the first thing to do is go to the network section and create a VPN. If you don't know how to create a VPN with a Palo Alto firewall, a site-to-site VPN, at the end of this video, you'll find a video on how to configure a site-to-site VPN. So, we need to go to Interfaces, then to the tab Tunnel, and we create a tunnel interface where, in this interface, I set the virtual router to default, the security zone to inside, and the IP is an APIPA IP address. So this is 169.254.0.1/30. On the right side firewall, you'll find 169.254.0.2/30, and that's it. There's nothing else to do here. Now comes the slightly tricky part. Once you've configured the entire VPN and you see that the VPN is up, by going here to IPsec Tunnel, you'll see that this VPN is up. Go to IPsec Tunnel. If the VPN doesn't come up, but in any case, this is a practice I recommend anyway. Under General, there's Tunnel Monitoring, and you set as the destination address the firewall. In this case, the one on the right, because that way the VPN stays up. Clearly, if you don't generate traffic, after a while the VPN does what it's supposed to do for security, meaning it disconnects, goes down. So by doing this instead, the VPN stays up. Just the default profile, that's all there is to it. The normal and standard configuration of a virtual private network or VPN is what we are discussing. Now, I absolutely need to tell the firewall system to carefully take these specific routes and then diligently send them via the Border Gateway Protocol or BGP to this particular firewall device over here, and then we will meticulously observe exactly how to accomplish that task. On the virtual router interface, we will proceed to the default settings, and then the very first and most important thing we must do. So we absolutely do not forget this crucial step later on, and especially because we will undoubtedly require it for subsequent configurations. We will navigate directly to the redistribution profile section. Here we need to tell it which networks we want to share, which networks we're willing to let the other firewalls see. So click on Add. Obviously, you create one. I've already created one. I called it Connected, but the name doesn't matter. You select Connected. Now here, there's also BGP. Maybe someone might wonder, what is this BGP? Well, if you select only BGP, you're telling the router here, the firewall in this case, to export to announce the routes that you receive via BGP, because maybe you receive some routes that you want to redistribute. Instead, connected means you want to announce, or more correctly, export, the networks that are directly connected to the router or firewall. So I have these two interfaces, 1/4.60, which relates to 192.168.60.0, and 1/4.70, which obviously relates to the 192.168.70.0 network. Then you click OK. Let me show you quickly. Go to Interface, Ethernet, and here you'll find the 1/4 interface with two sub-interfaces. And here they are, with their respective tags 60 and 70. All right, let's go back for a moment to the virtual router. At this point, still from virtual router default, let's go to BGP. So the configuration on the left is slightly different from the one on the right, as I mentioned earlier. That's precisely because here, the networks, the providers, the internet are connected directly to the firewall. So here, you leave everything as default. I set 4 bytes here, only because I can use longer AS numbers. So it depends. I recommend you select 4 bytes right away so you don't have to worry about it in the future. Then you select everything here, go to Advanced, and leave it exactly as you see it. Peer group, good. Here I have created 2 distinct peer groups, one specifically for the public ACEs, which are namely my providers, Provider 1, Provider 2, and Provider 3. And I created them, as you can clearly see. I meticulously entered the various AS numbers and so on, ensuring all the necessary details were included. You can readily find this complete configuration in the other dedicated video that specifically talks about the intricacies of BGP. Following that, I then proceeded to create another distinct peer group, which I named Verso Destra, and here it is, fully configured and ready for use. So what exactly do we have here in this particular scenario? Well, you can certainly configure this yourself, or at the very least give it a genuine try, which I would highly recommend doing. As you can clearly see here, it's already selected, so you simply need to click Add Peer. And then this rather nice, small and convenient window will promptly pop up on your screen. So, now for the name, it's crucial to give it a name that makes logical and intuitive sense for easy identification. Peer AS. This specific number is distinctly different from this other number located here. And that is precisely why I mentioned earlier that I would thoroughly explain it and then come back to this important point. Why is that the case? Because on the router on the right, you'll actually find this number, since the BGP network, that is the BGP peers, are created directly on the firewall here. Here, they're created on the routers, so this firewall doesn't even know what BGP is. This firewall only receives an IP address, which is 10.5, if I remember correctly, 4, which would be the public IP. Whereas here in this specific configuration, it receives it directly, and I want to emphatically repeat it one more time, just to be absolutely sure and crystal clear. Here, the Border Gateway Protocol, or BGP, is meticulously established from the primary router to the dedicated firewall, and conversely, vice versa. So, the peer configuration is slightly different from right to left, the configurations. However, that said, I hope this is clear, but if it's not, leave a comment below the video and I'll reply to you. No problem at all. Let's go back to the one on the left. This is the peer number that I assigned to the firewall on the right. Then here you select the interface where you want to route the traffic. It will give you the IP of the interface, which is 0.1. And then you will need to enter the destination IP address, which in this specific case is 0.2, which is the firewall on the right. Leave the connection option as it is. If you want, you can lower the keep-alive, but it's up to you. Leave the number of hops at 0 as default. Leave everything in advanced as default, and then click OK. Then we go to import. Import. And what do we want to import? Which networks do we need to wait for? Now, if you think about the IWS, basically it imports them all and exports them all. Then with filters, you filter the networks you want. But since we're not IWS, I'm going to specify that I want the 80.0 network, which is this network down here. I want this network, I want this firewall to send me this network, and in this case, the firewall on the left should wait to receive this 80. Export, obviously, the name says it all. Which specific networks do you actually want to export? So let's proceed to click here. Clearly, if you intend to perform this action yourself, you should navigate to Add, and then this small dedicated window will subsequently pop up. It is important to give it a truly meaningful and descriptive name. Here, you will observe that you absolutely need to carefully select the peer. In this particular case, you can clearly see I have several public peers displayed to the right, which are precisely the ones you observed just a moment ago. So, quite obviously, I will select the appropriate peer located to the right. Just a moment, please. Okay. For the match, here I will precisely specify which particular networks I genuinely want to export. In this specific instance, there are two distinct networks, 70 and 60. Now, if you so desire, you also have the option to aggregate them together. Here, it would effectively become a /19 subnet, which would then extend from 60.0 all the way to 95.0, if my memory serves me correctly, and I am not mistaken. I am just doing this entirely from memory as well, so please bear that in mind. But anyway, it should be a 0.0.19, sorry, a 0.0.19, then here you leave it blank because we're not interested in aggregate, unless you want to aggregate them, in which case you put a name here, select the prefix, so it would be 182.168.60.0.19. You do summary, and then here you put the ratings you want to, let's say, aggregate. Redistribution rules. This is the rule we created at the beginning. If you remember at the start, I clicked here on redistribution profile with net, and you do this right away, as I said at the beginning, because then when you get here, you'll find it with net. That's right, this is very simple. You just need to give it a name, and here you select IGP and leave everything else as is. Once you've done this, click OK, commit, and so on. And let's see what came out of all this. I'll show you both routing tables. So, let's go to virtual router, and then here on the right you find more runtime status states. Okay, this is our routing table. Let's go to BGP. Let's go. So just to show you, we have the peers established. They're all connected. Peer group, we have our two groups. Local RIB. So local RIB stands for, in fact, local routing information base. Local, meaning the ones I have on my router. Rebout, on the other hand, is routing information base out, meaning the ones I send, the ones I transmit. So let's take a look at this for a moment to help you understand. I have these routes here, these networks, see, 172.16.1.0, then 2.0, 3.0, 4.0, 7.0, 10.0, which is the network on the right, and so on. These routes here, for example, it's 65.0.0.2.0.0.2.0.0.2.0.0.2.0.0.2.0.0.2. Wow, that's a lot of 002s. Who is 002? If I go check, 002 is this one, ESP. So most of the routes I receive through this provider. So this is ES. Then we have all these 003s where I also receive the same routes, and why do I receive them? Good question. I receive them because I have carefully set up this particular provider, these specific routers, so that they can effectively and efficiently balance the incoming network traffic across the entire system. So both routers announce all the routes. And these three are also configured to announce the routes over 3 paths. Otherwise, I absolutely would not be able to see them at all. Here, for example, you can clearly see that I am receiving the 3.0 from the autonomous system number 65003, and also from 65002. If I look, 65002, 65003. So I receive both routes on these two providers, meaning on these two internet connections. Anyway, that said, let's get back to our VPN. Here I receive the network. In my local routing table, I have network 80. Network 80 is precisely this one on the right. And where do I receive it from? I receive it from the IP address 169.254.0.2, which is the peer we created earlier in the tunnel I showed you, from the right side peer. And the AS path, so our AS number is 64,927, which you won't find in this diagram, but I'll show it to you. Then we have our local networks. It's also labeled local, 60 and 70. Perfect. Let's go to reboot. On reboot, the networks I want to announce. that I want to export, as I told you at the beginning. The configuration of the left router is slightly different from the one on the right, precisely because on the left router I configured BGP directly. So here you'll find, see, eBGP external. These are the names I gave them and the public IPs. But anyway, let's look at the addresses we're interested in. And here they are, our peers. You write and you write. 60 and 70. If you want, as I already told you, you can aggregate them. Here I left them unaggregated just to show you that there are two, because maybe if someone sees them already aggregated, they might get confused and miss it a bit. Anyway, you can aggregate them even though this video is a bit advanced, but maybe someone is a little distracted in the morning or at night, you know, they're tired and don't notice. Anyway, I received them from this peer, from this IP address 01, so from my local interface, from my tunnel interface. Okay, now let's take a look at the router on the right. Still on the network, let's now go to the router device. Let's go to more runtime states. Let's go here to BGP. As before, peer, we have our peers, but in this case, I only have one. I only have one precisely because here, I don't have the public IP addresses directly connected to the router, but maybe that's not even the right way to put it. Because I do have the public IP address directly on the router, but I don't share the router, in this case the firewall. It doesn't directly manage the BGP routes itself, but rather these crucial routing paths are meticulously managed by the dedicated routers located here, which is actually a fairly common and widely adopted setup within many large-scale enterprise network environments. We currently have a specific peer configured, and if I were to go and carefully examine the details of this particular peer, allow me to display the comprehensive configuration for your review, you will observe the significant number I previously mentioned earlier in our discussion. If you recall correctly, you absolutely won't find this specific number present here if I proceed to check the current configuration settings, and indeed, here it is clearly displayed, the AS number, this very one. Note that the configuration, even for the VPN and everything else, is the same as the one on the left. Nothing changes. If I go here now, BGP peer group, we have a local RIB. As you can see here, I have fewer IPs precisely because, as I said, I don't manage BGP directly. So in my local routing table here on the left, I have the AT network, precisely because here I only have the AT network. Or in any case, that's the one I want to share. That's the one that's there. Because here on the AT network, there's only one network configured, which is the AT. However, in the local routing table, I also have the 60 and 70 networks, which come from the router, from the firewall on the left, and are installed. They are placed in my local routing table. So the router, the firewall, assumes that these networks are local and treats them as local networks. Then Reboot instead is, first, it's essentially the same story I meticulously mentioned earlier for the router on the left-hand side. It's primarily about the specific networks I genuinely want to announce, that is to say, the AT network. By doing this, my firewall now comprehensively knows both the left side network and conversely the right side network. Or if you happen to have more firewalls and a greater number of routers, it will consequently know even more networks. These are fundamentally routing-based VPNs. In other words, I carefully configure the precise networks I truly want to share, so I effectively install these particular networks on all the firewalls. Install in the sense that the firewall actively receives them, so they are indeed installed. They are precisely placed in the local routing table of the firewall, and I treat them in exactly the same way. Then I proceed to the policy section, where here, quite clearly, the policy is practically nothing because there's a very broad policy that explicitly allows everything, all protocols, and absolutely everything. So as a policy, it's not particularly restrictive. But then I go here to meticulously create my policy, for example, and I specifically identify the source as 192.168.80.100, which is precisely the IP address of the server, with a specific destination of 192.168.60, which is indeed the other server, for example, in this particular scenario. Right now, the current policy is simply to send everything wherever you can possibly send it. If, however, instead of this, I wanted to utilize a policy-based approach, which is perfectly acceptable and entirely fine if we're discussing a very small network setup, and in any case, one that absolutely does not possess a clear vision for future scalability precisely because of its inherently small size, then I would proceed to go ahead and create the VPN connection without needing to consider BGP and all of its associated complexities and so on. I would meticulously create the VPN, and then from there, here in this interface, I would simply add a new rule and explicitly specify the IP address 132.168.800 as the intended destination. Then I would give it the other corresponding address and subsequently set up the policy according to my requirements, and it would then function correctly. The fundamental difference lies quite clearly in the configuration process itself, even for the VPN connection itself. Because here, if I recall correctly, within the IPsec tunnel configuration, let me just quickly double check this. The proxy ID, I am required to explicitly specify which particular networks I wish to share with the other endpoint, and then subsequently, in the policies section, I instruct it precisely what kind of traffic to allow through, or conversely, what traffic not to allow through. So, this is basically the configuration for route-based VPNs, which you can also do with the OSPF. I chose BGP because it's the most commonly used protocol, since BGP is what the cloud uses. So if you want to connect your firewall to the cloud, you have to use BGP. If you were to use OSPF, then you'd have to redistribute the protocol and things get a bit more complicated. But if you're interested in that, leave a comment and we can look at it together in another video. For now, that's all. Thank you for watching this video. Leave a like if you found it helpful, a comment if you want to ask me something, and if you haven't subscribed to the channel yet, subscribe. Thanks, and see you next time.